Okay, so in the previous class or in the last class, we discussed about iBGP versus eBGP. We discussed about eBGP multi-hops. We also discussed about update source. Okay, so these were the topics that we discussed, and along with this, I have given you two assignments basically on these two topics. Okay, so I had done one in the class, and I had given you the second one as an assignment or something. Okay, and the answers were already on the PDF, so I believe you guys have done accordingly. And if there was any issue, I was expecting you would have shared any screenshot, but since there was no screenshot, I take it as good from everyone. Okay, and yes, at the end of the class today, I'll open up the syllabus PDF, and I'll just show you what are the topics that we have completed and what are the pending topics for CCNP Enterprise. Okay, but before that, let's do some topics for the day. Okay, because I don't want to waste the first half an hour or 1 hour on a PDF discussion, which we can do later on. And yes, I forgot to mention, we have also completed something called as BGP peer group. Okay, so in the class today, I want to discuss about path manipulation and path selection. This is one of the Enarsi topic. Okay, so the topic what we are going to check now is an advanced BGP topic, which is a part of Enarsi module. So under Encor, it was a basic BGP, iBGP versus eBGP, the different timers, all those things. Okay, whereas in your Enarsi, which is advanced routing and switching, it's where this path selection and path manipulation is being included. Okay, so let's discuss about path selection. So if I talk about EIGRP and OSPF, how were they selecting the path, or how were they selecting the best path? So the algorithm used to look for the shortest path to reach destination, right? So this used to be the algorithm, or this used to be the formula, or this used to be the concept to reach the destination. So it was a shortest path. And on what basis the shortest path used to be calculated? It used to be on metric. Okay, and EIGRP had its own metric formula, and OSPF had its own metric formula. In case of EIGRP, the metric used to be dependent on the 5 components like delay, MTU, reliability, then what else? Delay, MTU, reliability, load, right? And bandwidth. Whereas in the case of OSPF, the metric used to be on basis of 10 to the power 8, which was also called as reference bandwidth, divided by interface bandwidth. Okay, so these were the formulae to find the metric, and metric was an important factor to select the shortest path. Now in the case of BGP, the definition still remains the same: shortest path to reach destination. Okay, the definition is still the same, shortest path. But now metric is not one such criteria to select the shortest path in case of BGP. Okay, metric is not one such criteria. We don't have metric in the case of BGP. In the case of BGP, we call it as attributes. Okay, there are a couple of attributes. So if you see over here, I have done a flow chart. So basis on these many attributes, the path gets selected. Okay, so let's say I had a router on AS value 1, and this router was connecting to another router which was a part of a different autonomous system, let's say autonomous system 2. And similar way, let's say it also had another router which is again in autonomous 2, and then it used to connect to a different router on a different autonomous system, or any kind of uh, the network design that you guys have. Okay, so if the path, let's say if my packet, okay, my routing packet is moving on from one router to another router, so it's on these values. Okay, so what is going to happen, let's say if I receive a packet and I want to forward it to this is my destination. So what is my router 1 going to do now? So my router 1 is not going to see the cost now. Cost is not appropriate component for me to find the shortest path. Okay, R1 is going to see the first attribute called as weight. Let's say if weight is not configured, it will check local preference. Let's say if this is not fixed, or let's say two router have the same local preference, it will go to the next tiebreaker, originate, and so on. It will check one after one, and the criteria where it gets some information. Okay, let's take this criteria to make the decision. Let's decide whether to send to R2 or to send to R3. So this decision making is done because of these attributes. Okay, so we will talk about individual attribute. We will try to do labbing on each one of them so that we understand how the packet gets routed up. Okay, so altogether, if I just summarize, then you guys will not understand. Those who are aware of this, you guys can easily get through, but the one who are just going through for the first time, you guys will definitely get confused. Okay, so let me start step by step. So first, let's see what do you understand by path selection, or what is a best path selection in the case of BGP. So when we talk about update packet in BGP, what is the role of update packet? To advertise all the prefixes. It will advertise, it will talk about the prefix attributes, right? So every prefix, so let's say what is prefix. So prefix are nothing but those networks which are advertised over on BGP. Now let's say I have multiple prefixes. This is one prefix that is advertised. I have some other prefixes. Okay, I have still different kind of prefixes with me. Now each one of them will have its own attribute. Attributes are nothing but these parameters. So these will have different attributes. These guys will have different attributes, right? So who is taking care of this? It's your update packet, which is carrying the path attribute associated with prefix. From one router to another router, it's your update packet which is gonna carry this information. Okay, clear? One thing. Now second thing, BGP is gonna make best path selection on the basis of attribute. Okay, so it's not basis of metrics that we have checked in OSPF and OSPF and EIGRP. It's attributes now. It's called as attributes, and metric is nowhere one of the attribute. Okay, so we don't have attribute here called as metric. BGP attributes are similar to metrics in OSPF and EIGRP. That's right. In case of BGP, we call it as attribute, which is a decision maker, which path to be selected. Like how we have metric in case of OSPF and EIGRP. When you find a shorter path, OSPF will start routing the packet on that path to reach the destination, because metric plays an important role. In case of BGP, it's attribute. BGP use path attribute to pick the best route. Okay, it's gonna take attributes. BGP store multiple path to the destination in BGP table. That's true. If you see here in my BGP table, okay, you will see multiple path. But the one with the best attribute will be taken up and will be put up in the routing table for forwarding purpose. Okay, BGP path algorithm decide best path to install. That's something which I told. You will see multiple path, the one with the better attributes. Okay, the attributes are associated that I just told in the line number 1 or the point number 1. Every prefixes will have the attributes associated. Okay. BGP path algorithm decide best path. Fine. BGP goes through the following steps to select the best path. So what are the steps? It's sequential order. Okay. First, it will check what is the weight parameter or weight attribute that's configured. Let's say weight is not being customized. It's on a default number. Now that's a tie. Okay. So to break that tie, we will see the local preference. If the local preference is not been modified, we will see what is. Give me a second. Okay. So as I was telling, it's a sequential order. Okay, so first weight will be checked. If there is no way that the weight component is different, or let's say the weighing is being set up default, the next will be checked local preference. If it's again the default value on two routers or two different paths, then originate will be checked and so on. Okay, AS path, origin code, MED, multi-exit discriminator, eBGP over iBGP, shortest iBGP path to BGP, the oldest path, the router ID, and neighbor ID. Okay, so this is the way the usual calculation happen. If you see from my previous labs, the basic labs that we done so far, on which factor where the decisions were made. So let's say if I show you one of the example, let's say uh, the lab which we did in the previous class. Okay, so if you see this, okay, so this is a good lab to show you. Okay, so if you see this lab, okay, the first lab, when I configured the BGP, all the attributes were associated with the prefix. You will see here all the attributes are associated, and by default they are all on the default values. Okay, so the decision was made depending upon the last two factors. One was router ID, right? If I just take you back to that list, you will see the last two values here. What are the last two values? It's router ID and neighbor IP. If I don't have a manual configuration for router ID, it's then neighbor IP that's gonna get selected, and the lowest will win the election. So there is no way, or there is no such attribute mentioned here which could lead to failure of neighborship or failure of path selection, because these two are required every time. Because router ID, let's say it's optional, it's on you to configure or not. But what about the neighbor ID? That's something which we have to configure to initiate the BGP process, right? So let's assume this all options are kept default. Okay, and they are not a valid attributes to make the decision. So in that case, your BGP will still have the last factor, that is attribute 11 neighbor IP, to make the path selection. Okay, so never think that the whatever neighborship that we saw was happening all of sudden or without any theoretical approach. The approach was, it was considering the 11th attribute, that's neighborship attribute. Okay, let's say you want to change that behavior, you can set a router id and then you can just play around with that. Okay, so this is in basic level, just to manipulate in your lab or something. But when we talk about production, we deal with the first few attributes. Okay, and in the case of BGP, the packet manipulation or path manipulations are divided into two flows. Okay, so let's say this is my enterprise, LAN enterprise, and I have a router here, a BGP router, and I have two ISPs, ISP1 and ISP2. Okay, so how BGP is different than your OSPF or EIGRP is, you can tune your packet or you can tune your path selection. Let's say when the packet is moving in a outer direction. Okay, when a packet is moving outer direction, let's call this as a outbound traffic. To be more specific, it's a outbound traffic. My traffic is going out. Let's say I have users here and I have two ISPs, so I can just manipulate in such a way. I say that all these internet users, let them go to ISP2, and all my server traffic, let them go to ISP1. That's a outbound traffic which is initiating within my premises and going outside towards ISP. Now I can tune such traffic. Okay, how can I tune that? For that, I have to take two attributes which will be acting as my path manipulator for my outbound traffic. So that's one scenario for outbound traffic. Now let's say traffic is incoming. I have traffic coming from ISP1 as well as I have traffic coming from ISP2. And in such scenarios, let's say I want this ISP1 to be my primary, which carry the 80% of load, and I have the backup traffic which carry the 20% of the load. Okay, the total load or load sharing. Now that's a scenario which is called as inbound traffic. And to manipulate the incoming packet, you have other two attributes which will help you this. Okay, so from overall 11 attributes, it's your 4 attributes that is very crucial from manipulating point of view. But from certification and from interview point of view, you must know all the 11 and you must know what are they. But from production point of view, from manipulating point of view, it's your 4 attribute which can be used for your manipulating outbound facing traffic and inbound facing traffic. Okay, so that is why BGP is very different than the dynamic or the LAN protocol. In the LAN protocol, you can just change metric for incoming outgoing and there is no much option for you. But in this case, you can do or you can perform lot many advanced things to manipulate the traffic. Okay, so we will see one after one. For now, understand these are the 11 attributes. Now, are they only 11? Can't they be 17? Can't they be 20? Can't they be 25 attributes? So to answer you that, it depends on the vendor. So Cisco has like close to 13 or 11 attributes, whereas other vendors like Juniper or any other vendors, they have like at somewhere some 17 attributes. Okay, so since we are doing a Cisco certification, we will be more focusing on Cisco attributes. Okay, and the first one here, that is the weight, it's a Cisco proprietary. That means you will see this attribute only in the Cisco box, nowhere else. So you can just take it only 10. If you just take the first one out from this list, just considering this to be one of the Cisco proprietary, you are left with 10. Now you need to remember this on your own. There's no way that you can skip this. Very important from interview point of view. You should name them, and you should be able to write them in the sequential order. You just cannot write first router ID and then you go and write origin code and somewhere, and then you bring wait. It's a sequential order. Okay, so follow this pattern. It starts with, so let's say traffic first makes a decision on basis of weight. If weight is default, you have not tuned it or you have not manipulated it, the next attribute will be local preference. If that's, let's say that's a default, again it's gonna see originate, then it's gonna see AS, it's gonna see origin code, it's gonna see MED, it's gonna see the eBGP path over iBGP, it's gonna see the shortest IGP path, and then oldest path, and then router ID. And let's say all were default, there was no extra component which could make the decision. The last left out would be the neighbor ID, and depending upon the lowest neighborship IP, the path will be selected. So let's say I had R1, and this R1 had two ways to send the traffic. It was R2 and R3. Okay, and R1 is confused now whom to send R2 or R3. And let's assume all of them were default. Okay, all 1 to 10 were default. Now the last attribute, that is 11th attribute, that cannot be default value because every interface are gonna have their own IP address. So that's not going to be common for everything. So this, the 11th attribute will now be the decision maker. So whichever interface, if let's say this is 2.2.2.2 and this is 3.3.3.3, now how is the decision made? On the lowest neighbor ID. So R1 will send the traffic to R2. Okay, so that's how the path selection is done in the case of BGP. Okay, so we will discuss this one after one. Don't take it in a complicated way. And to help you, this is the flow chart. It follows this order. Okay, fine. So let's move on to the next topic. It's path attribute. Okay, so what we discussed here were the attributes. Now these attributes are being simplified into 4 different states or 4 different categories. Okay, so the first one is called as well-known mandatory. The second one is called as well-known discretionary, and the third one is optional transitive, and fourth one is optional non-transitive. And all these 11 attributes, okay, some of them are placed here, some of them are placed over here, some are over here, and some are over here. So that's how the four categories or the 4 classified ways has all these 11 attributes within them. Okay, so let's see what are they. Why do we need this 4 classified steps, or why do we need this different states? So the first one, well-known mandatory, it's about including the parameter in every advertisement. So if I'm sending an update advertisement, okay, so my update advertisement is going to carry those attribute along with the prefix. Okay, so let's say I have 5 different prefix that the 5 prefix that are getting advertised, like 1.1.1, 2.2.2, 3.3.3, 4.4.4, and 5.5.5. Each prefix will have their own attribute, and the attribute are gonna be carried along with the prefixes. Now such kind of attributes, the attributes which are going to carry the prefix which are going to be carrying the attributes along with it, or let's say attribute which move from one router to other router, they're called as well-known mandatory. Okay, so that's an example. So the example for well-known is, you can see this chart. So I have BGP attribute divided into 2. One is well-known and optional. Well-known is again divided into 2, and then mandatory has these many attribute. The second one has these many, transitive have these many, and non-transitive have these many. So totally all 11 attribute divided or classified into 4 major components. Okay. So what about the second one, well-known discretionary? So in the case of the second one, they may be or may not be included while advertising. They are not 100% included. They may or they may not be. That's a statement for the second one. Okay. Whereas the third one, optional transitive, it's when your BGP routers do not have to recognize them. Okay. They are optional. They don't have to be recognized them. And you can send or you don't have to send. So they do not have to be recognized. They can be transitive and stay with the route advertisement from AS to AS. When I have multiple AS, AS1 and AS2, so my third one, optional transitive, they can be recognized between the routers or they can be sent. Okay, it's all depends on what we configure. So that's about the third one. And what about the fourth one? It's when you cannot share it. You don't have to share it. Okay, it's remain on the local side. Whatever you configure inside it, it's gonna remain within that router itself. They're not going to be carried upon. Okay, so these are the 4 states, and the 4 states are containing all other attributes. So the example for the first classified state are AS path, next hop, origin. So this is internal or iBGP, external BGP. Okay, and this is when you don't have a active state of iBGP, or you do not know on which BGP have the neighbors learned. So you have this question mark. The second state where you have local preference and atomic aggregate. The third state, the third classified state, where you have aggregator, community, and under community you have sub components like no export, no advertise, internet, local AS. And in the last one, non transitive, you have MED, multi exit discriminator, originator, cluster ID. Okay, so out of these 11 attributes, as I told you, the 4 attributes are very important, which you will deal with production. Okay, in the case of production environment, to manipulate the incoming traffic or manipulating the outgoing traffic, you will deal with these 4 attributes. I'm going to tell you which all. Okay, I'll tell you what all are they. Okay, so same thing, it's rewritten with many points. Okay, for your reference, so you can read it during interview or while preparing for the certification. So it's all about what is happening and what are the examples. Okay, and for your understanding, I have attached one of the screenshot from our previous lab and I have written. So these are all attributes that the attributes that we are discussing about. Okay, so you have the attribute which is gonna say whether it's a internally learned routes or it's gonna be a eBGP. The next hop attribute, you have your metric attribute, you have the local preference, you have weight, you have the AS path attributes. Okay, so you have multiple attributes, and for your reference I have attached this. Okay, fine. Once again, another chart just to make it more simplified. Okay, so these are gonna tell you the first example for the first state. You have the second one. Okay, and then you have the third one here, and then you have the last one over here. Okay, and what are they and on what basis are they classified? So when I say that they are classified into 4 state, the 11 attributes classified into 4 state, that's because of some behavior, right? So those are the behavior that's mentioned here. Okay, what are they? On what basis have we classified these, the four states? But yes, these are important, but the challenging part is this one. Okay, the 11 attributes, you must know it in a order on which level the decision is made to see the path. Okay, fine. So that was regards to the attributes, and that was regards to the path selection. But in the case of BGP, as we know, it's a protocol which runs over internet. So there will be several prefix online, or there will be several prefix on your internet, right? So each prefix can have its own attribute. So let's say, just let's talk about only from your LAN point of view. You have multiple prefixes. Okay, you have a prefix list with 13 series, you have 14 series, 15 series, 16, and so on. And each one of them can have their own set of attributes. Okay, so let's say they have their own set of attributes. So who is going to take care of these attribute and these prefix? It's your network layer reachability information. In BGP, we call it as NLRI, network layer reachability information attribute, which is consisting of prefix, prefix length, path attribute for that particular route. Okay, so that's why even in the previous class, I remember at the end I told you that you would see multiple update message, because for every prefix length or prefix there would be one update packet, right? And who is gonna carry the information that this update is for so and so network, whereas in this update message, the packet would be for a different prefix, right? So they are all about NLRI, network layer reachability, and this is the Wireshark capture. Okay, so when you have Wireshark capture and when you have multiple routes advertised, you will see that the NLRI is gonna carry the information. So you will see this component getting repeated, and it's on update packet that you see this. Okay, so a quick summary about what we learned. BGP path selection done on best path algorithm. It make uses of various attribute for various attribute assigned to every route. Okay, it's not a global component and all your 10 routes are associated with this. It's not that way. Every route will have their own attribute, and that's taken care by NLRI. Okay, BGP attributes are similar to OSPF and EIGRP metrics. BGP select the best path on the list of attributes. BGP use attributes to select the best path. BGP has 0 to 14 attributes for Cisco. Okay, when we talk about Cisco, there are 0 to 14 attributes. For vendors, it's 1 to 14. BGP does not use metric but use set of attributes. So BGP is not gonna look for the cost of interfaces. It's not dependent upon bandwidth or load or reliability. It doesn't need them. It is only going to see the attribute. It's you guys who are gonna tune your packet that's going to ISP, and you're gonna tune the packet that you're going to receive from the ISP. So everything should be under your control. It's not that you have advertised and something has been done and then you're suffering from the slowness or internet connection or all those things. It's all up to you. So you can tune your packet with the attribute. If you think the ISP2 is giving you high latency, you can just change the attribute so that path takes the first one. or the first ISP. Okay, so that's all about manipulating. And as I told, there are four main types which is mentioned here. And yes, the traffic manipulation, the very important thing. When you have inbound traffic manipulation, so let's say this is your LAN, okay, and you have routers. Let's say this is connected to ISP1 and this is connected to ISP2. Okay, so let's say you're receiving some traffic. So you're receiving some traffic from both the ISP. So such traffics are called as inbound traffic or incoming traffic. So these are the traffic which will come inside to our distribution and then go towards the server or whatever. Okay, so let's say if a customer is browsing through our infrastructure to reach to the server. Okay, so these kind of traffic can be manipulated by these two attributes. It's called as AS path and MED, multi-exit discriminator. Okay, so these two attributes will be used for incoming path manipulation. At the same time, when let's say I have users, multiple users, and the traffic is going outside or out facing. Okay, so for outbound traffic manipulation, you can make use of wait or local preference. I say or. Okay, you don't have to make use of all of them, all the four. You don't have to do that. You can make use of any one. So let's say for outbound traffic, you want to make use of wait. Okay, let's say this is something which you cannot achieve because of your design. So in that case, you can make use of local preference. So when to be used these attribute and on which scenarios to go with the second option is something which I'll tell you while doing the lab. Okay, so to perform that lab, we need a different set of topologies. Say for example, what I did is I just added up one more block. Okay, because I was not able to achieve these attributes on whatever we had in our lab. So I just added up three more to show you a simple lab where I can demonstrate this attribute, wait attribute. Okay, so I'll do this lab, or I can also pass it to you guys. I have everything mentioned on my PDF, so I'll just talk about that. Okay, so let's talk about these two things, very important. Whenever uh, so I'll tell you a scenario the interviewer is gonna ask you. Okay, so usually what happens is the interviewer is gonna draw a LAN part. He's gonna say this is your BGP router or edge router. Edge is nothing but facing towards ISP. Okay, and he would say that he wants to manipulate traffic. He would set some criteria that I want 1.1.1 to take ISP1. I need 2.2.2 to take ISP2 or whatever. Okay, and he would set you some time, or let's say 10, 15, 20 minutes. So don't get confused. The first question that you guys need to ask is whether he is trying to manipulate the inbound traffic or outgoing traffic. That's something which interviewer is gonna tell you, and on that basis you're gonna recommend what attributes that he must use or what attribute that you can use to manipulate that. So the first question that must come to you is it about manipulating the incoming traffic or outgoing traffic? That's the first question. If we say okay, it's about the outgoing traffic. Now when it's about outgoing traffic, just take this out from your ideas and just think about these. Okay, so when to be used wait and when to be used local preference. There are some limitation for wait when I just cannot go with this and I have to go with local preference. Okay, so in such scenarios you have to take out wait and you have to prefer local preference. Okay, so that's a small interview from an interview point of view, that what I have seen, technical panel going to ask you in case of BGP. Okay, they are going to give you scenarios, and then they would say that I want this, I want that, I want this network to take ISP2, I want that network to take this, and so and so. But the first question that you need to ask is, what is the traffic that they are trying to manipulate? Are they trying to manipulate the incoming traffic or the outgoing traffic? If they justify that, then start working on these attributes accordingly. Okay, the attribute which is for inbound traffic manipulation, and the attributes that's for the outgoing traffic manipulation. Okay, so I hope this was clear, the basics on the path selection and path attributes. Now what I'm going to do is I'll talk about one at a time, that is one attribute at a time. So I have the weight for now, because that's my first in my list. Okay, so when I have the first attribute, so let's say from my router point of view, it has this path as well as this path. It could have sent to R2, or it can also send to R3. Now, what is the decision maker? So the first attribute here is weight. And as I told you, it's a Cisco proprietary. So let's assume they are all a Cisco box. Okay. And this is a valid point to check the path selection, or to make the path selection. And which attribute or which router is gonna win the election? It's the one with the highest weight. So these are also very important. Don't forget, because for some attributes it's about highest, for some it's about lowest. So you must remember the bindings. Okay, weight is highest, local is highest, originate is local. Local in the sense, locally originated routers are more preferred than external routes or external incoming routes. Okay, AS path shortest AS path, in the sense the two AS which is next to next, instead of 10 different AS in a list. Okay, so the shortest is considered. Origin cost, or the origin code. So you have I, you have E, fine. Multi-exit discriminator, where you have two multiple paths to go to two different ISPs. eBGP over iBGP. This is purely about AD values, administrative distance. Okay, eBGP is preferred. Shortest IGP path to BGP next hop. So interior gateway protocol preferred over on BGP's next hop. This is more better considered. Lowest IGP metric. Oldest path received first. So oldest path versus newest path. So basically oldest gets selected when compared with the newer part. And when it comes to router ID, it's your lowest that wins the election. If there is no router ID, it's your neighbor address with the lowest neighbor ID that's gonna win the election. Okay, so the first one here is weight highest. So let's see what do we have about weight. It's a Cisco proprietary. It's local to the router. When I say local to the router, that means it's in scenarios where you have only one router. Okay, and you have two outgoing path. Okay, so what is a weight example for? It's an example, or it's for path manipulation for outbound traffic. So we need to talk from the outgoing traffic point of view. So let's say I have ISP, AT&T. Okay, so AT&T are giving me two of their routers, and this is my enterprise. So my traffic can go towards R2, or my R1 can take the R2 path to take to the next hops. Okay, so in such scenario, when I'm having only one router on my side, and on the ISP side, on the similar ISP, on the same ISP, I'm not talking about ISP1 and ISP2, they are a single ISP but two routers. Okay, so in such scenarios, I can make use of a weight attribute. It's very simple to configure and test. Okay, but weight are local to the router. Let's say if I had an additional router here, so this connecting to this and this connecting to this, so in that scenario I cannot make use of weight because weight is locally significant. How is my router 2 gonna know what is the weight I have configured on the second router? They're not gonna communicate. Okay, it's an example of those non-transitive. They're not gonna send that in the update packet. Okay, so when the update message is being sent between R1 and the second router, they're not gonna carry the information about weight. It's locally significant. So that so in such scenario, in scenario where we have only one router, is very simple. I configure weight and I can manipulate the path. Okay. Well, so what about weight? What else about weight? So weight is something which is preferred on a higher values. So you have a higher weight and you win the election. You will send it to the R2 if it has a higher weight. By default, or these are the numbers that BGP weight attribute is gonna support. So you can change the weight value anything between this range. But by default, you're going to have this weight considered for those routes which are locally learned. Okay, say for example, if I show you my show IP BGP output, so you see the weight over here was mentioned to be 32768. Okay, the reason is it's internal route. It's a default internally learned route. Whereas if you see the weight got decreased to 0, this is when they're having eBGP relation. Okay, so let me draw an example. So let's say this is AS1 and AS2. I have routers. Okay, so whatever routes I learn over here, by default the weight would be set to 32768. But the network, let's say the prefix 4.4.4, which is here, if this prefix you're learning here, then you're gonna have the weight to be set 0. Okay, it might look little confusing, so that's why I give practical scenarios. Okay, so that you configure on your own and you try to analyze what is happening in the backend when you configure them. So on a iBGP, weight are gonna be 32768. On an eBGP, on a prefix that's learned from different AS, the weight will be set to 0. Okay, so that's a default behavior. So if you see this, the path that originated have 32768 by default, whereas the other path are gonna have 0. And the highest one will win the election. Yes, you have 3 ways to manipulate the path attribute. Okay, so when do we need to manipulate the path attribute? So let's say this diagram. So let's say this could have sent to this router, R2 router, or this could have sent to R3. Okay, now let's say by default it is sending to R2 because of the lowest neighbor ID, but I want to prefer this. So what I can do is I have 3 ways to change the behavior. And what are those 3 ways? The first one is about so the first one is about change the weight attribute basis on the neighbor statement. Okay, I write neighbor, let's say the neighbor R3 IP, and I just say the weight is gonna be 500, and on the other side the neighbor R2 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 R2, I'm gonna set a weight of 0. Okay, by default this was getting preferred because of the lowest neighbor ID, but what I need is I need this to be preferred, so I just manipulated my weight command. Okay, so the higher one wins the election. So this automatically gets the path now, or this has been preferred. Now you can also change them depending upon the AS path access list. Okay, so you can write AS path access list to change the behavior. So let's say you don't want to go with this, you still have the second way to change the weight attribute. So this is that command. Okay, if you see, this is going to be the second way of changing the weight command. So this method will apply the weight value to AS path defined in access list. And the third method is route map, which is considered to be complex definition. But yes, we have route map, which I'll definitely tell you what are route map. Okay. And along with route map, I'll also discuss about prefix. Okay, so I'm gonna discuss two things with respect to BGP path manipulation. I'm not sure whether this is a part of CCNP or it's a part of CCI, but I think this topic is important from a technical point of view. Okay, so I'll discuss about path manipulation, where we will talk about on the basis of prefix list and route map. Okay, when an interviewer say that I need so many networks, let's say first 5 network on ISP1 and the next 5 network on ISP2. Okay, so to do that, to achieve the result, you need to make use of prefix list and route map to uh, get it doing. Okay, so we'll set up a lab. I'm pretty sure with this lab I cannot do, so I'll just try to extend this part, and yes, I'll send you this topology, or if you have the instance, you can just drag them and place them. Okay, so as of now they are only 3 in triangles. Okay, in future what I'll do is I'll just keep adding few modes in something in this type. Okay, where we can see other attributes like weight, AS path, local preference, MED, where we can do these attributes, and I can show you prefix list, route map, and all other parameters. Okay, so as I told you, one after one. So for now it's about weight. Okay, so what is weight used for? It's used for outbound traffic. It's locally significant. It's not propagated to other routers. And yes, how can I manipulate weight? It's because, or it's on these 3 ways I can change the weight command. It's a neighbor command, IP, AS path, and the route map. So 3 way to change the weight. So fine, I have one lab, a very short lab, and this is one topic which I have for today. Okay, and yes, let me describe about this. So let's say this is my enterprise here, and I have ISP. Okay, and the ISP is giving me 2 routers on their side. So it's about outbound traffic. As I told you, weight is about outbound traffic. So traffic can go over this or over this to reach this loopback network. Okay. Let's say I want to reach 23.23.0/24. So it can go over this or over on this. And since I have only one router on my end, I can make use of the weight attribute to change to change the behavior, to change the path. Okay, so by default what is happening? So let's say if you see from the IP point of view, I have 12 series network on this side, and on the other side I have 13 series network. So I want to know from you guys, what is the path that's gonna consider by default? By default, is it gonna take R2 or is it gonna take R3? Just from the IP point of view. So let's see how many of you are with me. Okay, R2, R2. Okay, fine. Yes, that's true. Okay, and that's what also I have achieved on my lab. So by default, it was taking the R2. Okay, the reason is because of the lowest neighbor ID. But my requirement now is I want R3 to be taken. Okay, instead of R2, I need R3 to be taken. So what I just do is I go to my R1. Okay, because R1 is my router, enterprise router. This is on the service provider. I don't have any control onto these routers. I cannot change anything. I can only change parameters on my router itself. So what I do is, as you know, weight can be manipulated on a neighbor basis. Agree? So what I just do is, so let's say over here, my neighbor statement is neighbor. Let's say it's 192.168.12.2 remote AS of 2. Okay, so this was my default configuration, and the next route is 13.2 remote AS of 2. Now since I'm manipulating the weight configuration, I'll just write the new statement saying neighbor 192.168.12.2, and what is the weight going to be? So I'm gonna set a low weight value. By default, they will have uh, let's say they have 32768 weight on both the sides. So by default, let's say they have 32768. So what I do is the route which I do not want to prefer, I'll set 0, and the other neighbor, that is 192.168.13.2, I'll set a better or a higher weight number. Okay, so I'm gonna set 500 here, and I'm gonna set 0. So what happens? Automatically my traffic will now be considered this. But the thumb rule is, or a mandatory command here is, whenever you change the path attributes, the changes do not reflect automatically. You need to forcefully flush them, okay, with this command. So when you do clear IP BGP star, the attributes will get re-triggered. Okay, the update message will carry the updated attribute, and that's when you will see the traffic has now gone out of this direction, and now this has been taken up. Okay, something like this. So you see the best path now elected is 13.3 and not 12.2, because I have set a better weight for my 13.3 network. Okay, and what is that flushing command? It's called as clear IP BGP star. So do you think you guys can recreate this and practice? I have done all the configuration, I have done all the screenshot, but I want you guys to practice this. Something which you should. Okay. Okay. So any question with regards to this? Any challenge? This is very simplest of what I can give you at this minute, because uh, starting of the batch we had Monday to Friday, and then we said Friday will be for practicing, right? So I want you to have the maximum scenarios topology from my side, so that you can get it done on the weekends like Friday, Saturday, and Sunday. You have 3 days, and these are all shortest lab that I can give it to you guys. When it comes to any complex, I will of course do on the uh, class itself, and then I will try to give you a smaller part where you can get it done. But yes, since you all are CCNP folks or CCNP guys, so doing this should be this should be something mandatory, so that you can grab the things and grab the theoretical approach. Okay, and just to make it easy, I have given all the screenshot, all the theoretical explanation, what is what. And I just want you guys that whenever you finish with your uh, weight attribution, or whenever you change the weight attribution, the end result should be this. Okay, this is something which you need to achieve out of your lab. This is the end requirement, that your destination is now preferring 13.3 over on this weight. That's something which is a expected result from this lab. Okay, fine. So that's from my side. And yes, you guys can bring up your doubt, and at the same time I'll also show you the syllabus copy, and let's see where do we stand. So I have Encor and I have NRC. Okay, so I'll just highlight the topics that we have covered. Okay, so we have covered the first few topics. Okay, FHRP covered, redundancy covered, SSO I'll take you some other time, but it's just a describe, okay, just a theoretical topic. We are left with VLAN. We have done on-premise and cloud. We are pending with SD-WAN, and SD-WAN is something which I want to give you a very good class or presentation. So just I want to understand how many of you are aware of SD-WAN concepts? Just yes or no, or just. So how many of you are aware of SD-WAN components, the control policies, the templates? Okay. Yeah. So the reason why I want to take this in very good way is this is something which is emerging at this at right now, right? Everyone are talking about SD-WAN, 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 right? So that's why this is again just a describe which I can cover in 1 hour or one class, but I want to give you little more on some like initial deployment, or kind of the policies or templates, the NAT, a little bit more on SD-WAN. Okay, so which will do it on like completion of certain percentage, not now. Let's finish all these configuration kind of topics first. Yes, we done with SD access. QoS is pending. We have covered the hardware and software switching on very first week, about the routing information, all those things. We are left with virtualization, VRF, and Lisp VXVLAN, okay, which we will do later on. From the infrastructure, we have covered all the switching topics like .1Q, Ether channel, spanning tree, RSTP, MSTP. We have done EIGRP, OSPF, and yes, we are going through EBGP, but I'll just mark it as done. We are doing currently the path selection and neighbor relation, so we are almost done. Okay, but let me mark it. We still have 2-3 classes for BGP, so don't get panic. I'm just marking it. Okay, wireless, nothing done. IP services, I think we have done with this one. Okay, and we have additionally done GLBP also, which was a CCI topic, I guess. Fine. Network assurance, nothing so far. IPSLA, DNA, work center, netconf, okay, nothing so far. And from security, AAA, ACL, control, plane policies, REST API, threat zone, okay. So these are all pending topics, and if you see them carefully, you have 15% on automation, which is 1 or 2 class more maximum. On the security part, it's 20%. Again, you have like few of them configurations like ACL, AAA, which you guys are already CCNA guys, so you know how much time are they going to take. It's a matter of uh, a few classes only, not they're not going to be very complex topics. Okay, just the line VTYs, the AAA authentications, ACLs, and rest are described. So might be 3-4 classes. Let's take it as 3-4 classes. Okay. From the network assurance point of view, you have diagnosis, which is how debugs work, how traceroute work, how the ping works, which I have described uh, in some classes, might be in the last class as well, but I'll take it in very good way in a new presentation. For SNMP and syslog, I'll do a lab and I'll show you the packet captures and all those things. Okay. What else you have here? Syslog, you have NetFlow, you have span, you have IPSLA. Yes, all straightforward question, all straightforward topics. So let's assume another 3-4 classes for this topic, or might be 5 classes. Okay, rest are just the describe and all those things. And over here, wireless is something which is again described. So it's all described or the theoretical topic. So might be it take 1 week for wireless to discuss in a very broad way. If I'm doing some lab to show you the VLC controllers, all those things, let's take it as 1 week. NTP NAT multicast, another 3 or 4 days. Okay. And over here, virtualization, which is just 10%, might be 2 or 3 days. Okay. So let's say 10 classes on Encor side, and from NRC side, let's see what have we done. So on the NRC side, we have discussed about administrative distance, which is uh, regards to the AD values of every protocols. Tagging, filtering attributes is regards to route map. Okay, which I'll take it in the next classes. Loop prevention, that's filtering, tagging, split horizon, route poisoning, which I'll take it once again in separate class, because I know you may not have uh, got it in a well way when I was talking about EIGRP and OSPF and BGP. So I'll just take it point to point so that you guys have a clear understanding. Okay. Redistribution, yes, we will do that. Auto summarization of any protocol, we've been doing for every protocol individually. For EIGRP, I have done auto summarization. I have done for OSPF, and also I'll do it for BGP. Okay. Policy based routing, yes, we will do that. VRF, yes. BFT, we will do a lab and I'll try to show you. It's a simple topic, not much. From EIGRP point of view, we have done the we have done the NRC. We have done yes, we have not done IPv6. I'm just marking it. Don't get panic. We will do IPv6 on a separate node. Okay. We have discussed IPv4. We have discussed neighborship relation authentication. We have discussed all the loop free path selection like RD, FD, FC, successor, feasible successor, and SIA mode. It's a path when you have lost your main, you are lost with your secondary path and you're just stuck. You don't know what to do now when two routers are active. Okay. Stub, load balancing, equal and unequal, we have done a lab, and also metric. Similar way on OSPF for IPv4, we have done all the topics from NRC as well. All your NSSA, ABR, ASBR, internal routers, point to point, all the neighbor relation, authentications. Okay. The path preference. From BGP point of view, yes, we are getting with IGP and eBGP. We are going through this IPv4 address family. We have done next hop. We did multi hop. We did 4 byte AS. Private AS is pending. Route refresh is pending. Synchronization is pending. Operations is pending. Peer group done. States done. Timers done. Okay. I'll just mark this because I know what is pending, and that will be covered in this week for BGP. Path preference, yes, did it today. Route reflector pending. Okay. policies in and out, and path manipulation. This is something which we will be doing. Okay, so let me mark BGP as completed. At the end of this week, we expect that all these BGP topics are being completed. Okay, VPNs complete pending. There's nothing that I have done so far. Net infrastructure security pending, all the topics. But if you see, a lot of topics are being repeated from Encore and NRC. Like, you have the control plane ACLs, you have AAA. So basically they are the topics that's over here as theoretical, and on a NRC side they are troubleshoot or configure. Okay, at the end they are both the same. So what Cisco has done is, theoretical topic they have placed in the Encore, and on the NRC side they have placed the configuration. But when you talk about CCI, the CCI lab, you need both of them. Without one you cannot in future in future you cannot attempt your CCI lab. It will be a half knowledge or something. Okay, again, infrastructure structure services like VTY, console, HTTP. Fine. So these are all topics which are repeated. So I'm not going to consider these are separate number of days. A lot of things will be taken up while discussing these topic. I cannot just tell you theory and I say the topic is done. So no one is gonna be helpful, right? So when I have SNMP syslog, what I'll do is I'll do a lab. I'll show you the Wireshark capture. I'll show you the packet flow, the source and destination, the packet port numbers. So if you see the net flow, span, IPSLA, they are the same topics that's getting repeated here. IPSLAs, net flows, the SNMP. Okay, so that ends your NRC. So yes, I guess it should be 1 to 1.5 month, might be July end. So we are over here, and maximum, yes, July end. So my point was that let's not rush. Okay, and at the end I don't want you guys to tell that I'm faster or I'm not giving you guys enough time to practice. That's why I keep giving these small uh, topology, so that you can just practice it. It doesn't take, I know you guys work for 8 or 10 hours, and giving you a scenario, a complex scenario, and expecting on a mid weekdays is not very logical, right? This is very simple thing which you can do it, and you can just understand the packet flow. If you don't have time, don't worry. These are the screenshot that's gonna help you to understand what happened, uh, what happens when you do this. Okay, I've just tried writing everywhere what you expect. Okay, so any doubt? Do you need this highlighted ones? Do you think it's required? If so, I can pass it. If not, then it will be with me. So no worries, I'll just pass it after the class. Okay, let me see what questions do you have. Okay, so yes, so this is one. Might be you guys would be thinking, why not we ask ISP to change the attribute? But that doesn't happen all the time, because let's say ISP is over here and they do not want to change the attributes on their side. So it's now left on to you guys to change the attributes. So that is where you have the attributes on your side which can be changed to manipulate the traffic. Okay, so to answer this, as I told you, weight is a Cisco proprietary. Okay, whereas those four classified is a general topic. But yes, you can take it as an example for non-transitive, optional non-transitive, the last one, the fourth one. What is going on with the BGP routers in purple zone? You mean to say these, right? So I guess you refer to this. So this is for full mesh, and route reflector. Okay, in the case of iBGP. Okay, and for SD-WAN, I see a lot of yes. That's interesting. Well, not Meraki. I'm talking about. Yes, Meraki is also SD-WAN vendor, but I'm talking about Viptela and the C edges. Okay, management plane, control plane, data plane separation. Yes, OMP is the overlay management protocol, which has 4 packets or 4 tables. Okay, which is very similar to BGP. Like for example, in case of BGP, we have attributes, right? To change the path, or we manipulate the path uh, on BGP using the attributes, the 11 attributes. Similar way, in the case of OMP, which is a service provider or a SD-WAN, not service provider, I would say SD-WAN protocol. So it also has some attributes like TLOC, TLOC, and there are a couple of attributes here in the case of OMP, which are different than BGP, but yes, they work overall on a similar concept, that you can manipulate the changes, you can uh, manipulate the path. Yes, that's for route reflector and what do you say, full mesh. Okay, can you give an overview on the community attribute? Fine, so that will be taken up when, as I told you, we will be doing one after one, not all on the same day. Might be in the next class I'll take the next attribute with a lab. Okay, so over here, your question is over here, right? So we have few of attributes, and then we will eventually come here. So any further doubts, guys? I hope you are with me and we are not losing uh, one among others. Okay, because I felt some classes at the end, the impressions were not good. I felt that you guys have not taken me, or might be I included multiple topics. So so anyway, if you get stuck any point, let me know. Okay, so that I can at least cover it once again in the next class. So any further doubt before I can wind up for the day? Are we good? Okay, great. So yes, do your assignment. I'll give this document. Might be I'll upload it in some time and I'll give you the link. Practice it, and if you face any issue, let me know. And let's meet in the next class with a new topic and see you then. So have a nice day. Take care, everyone.